So just to recap what we have done in part 2, we have done stepwise regression, then we've plot the um, uh, squared regression. Then we also looked at the residuals, looked at the prediction, and so on and so forth. So this is the third part of the series. We are looking at something called k-nearest neighbor classifications. As the name suggests, it's kind of neighboring, so it's kind of clustering all the data set together. So like in a bunch of, if you think in terms of data set, and if you have a scatter plot everywhere, if you want to see region wise, or if you want to see, so for example, fruits, so if you want to see a bunch of apples and oranges and mangoes, and they'll be clustered differently together on the same graph. So this is what it's trying to say. So what I've done is here is you need this library called class, then the training data set. So what we are trying to do is train, you need, these are reserved word for this library. So we are training on training data. Remember, in first part we split data set into two parts: training in as in 75%, and the test is about 25%. So if you apply that, and if you were to result, if you see, you can see, so about 20.8. There are like 5 different data entries which are close to 20.8, and so on and so forth. The highest numbers are on top, so it tallies up. So intercepting the data goes as follows: like five entries for 20.8 bucket. So if you see that is a bucket, 4 entries for 14.9, and 4 for 21, 3 for 18.6, and so on and so forth. The bucket with the most heats are portrayed first, and then in the order of descending occurrence. I mean, this is very useful when it comes to frequency, to see what frequencies numbers are. So what frequent numbers are occurring. So let's plot frequency. So it says plot, then I would say KNN model, and if I was to plot this, and if I was to move this to my left, and should see nice graph. Okay, interesting. Yeah, so you can see this as the k-means cluster. This one suggests we've got 21%, 21.5 frequency for 20 point. Let's look at the scatter plot for MDALE. So it just looks like this. So you can see probably some outliers from this kind of linear line scatter plot. You can see just visually you can see that there appear to be a good match. The upper right tail is sparsely populated, and the mid left section is quite heavily or densely populated, matching our KNN result. Let's look at another machine learning algorithm which is called naive Bayes. It is the process of determining classifiers based on probability, assuming the features are independent. We can use one of the package called E1071 to use naive Bayes function. Let's try install package let's say E1071. Before that, let me just check if this is in my if I've previously installed it or not. So I'll just check library, and I would say E1071. Oh, it seems like there is. So yeah, there is. I've installed previously. I must have been playing around with it. So we already have that library. So now let's go and plot this now. So let's plot this and see. As you can see, one means this one means mean, the average, and the second number 2 means standard deviation. So here we see that the text appear to have very small effect on the dataset. So if you were to remove that text column, it won't make much difference. This is what it means. Let's look at another algorithm which is called a priori. So let's plot that plot, and I'd say N B a priori. Let's see the frequency. Yes, you can see it's quite 19 to 20 is quite densely populated, and you can see nice bell shape, curved. So let's look at another machine learning technique, which is called decision tree. In order to do that, you need a package called rpart. So that's my model for decision tree. And if you have to look at, if I was to expand this, zoom in, you will see something like this, like a hierarchical. While the plotting is not great, it's not great, but you can follow the decision point to arrive at a valuation fairly easily. You can come from, if L state is greater than or equal to 7.5, then go here. If not, then this side, and all that. So let's generate the predicted value using the test data as following. So it goes like this. So the prediction goes like this: nearly 4,000, which is just for comparison. This is kind of not good, not the kind of results we were looking for. It's a worse result than direct linear regressions. Maybe if the data were non-continuous, this would be a better modeling technique. Let's look at another technique, which is called neural network. Yeah, so I didn't have that package, so I had to install that package called neural net. Let's call that package neural net. And yeah, when I run this code, somehow I got an error. Then I ran this bit, which is more simpler code. Then it worked. But let's see what error I got. Yeah, as you can see, the error goes something like: algorithm did not converge in one-of-one repetition within the step max. Well, then I just ran simpler model, simpler function, I should say. And when I plot this, I get something like this. So let's zoom out and see if we can comprehend this. So plotting this further, we get something like 11,000, which is not that great. But let's have a look another function called random forest. Let's see what this gives us. Random forest. So you might be thinking, what on earth this random forest means. Random forest is an algorithm where each data point is developed into a large number of trees, just like in a forest. So you can imagine a tree and it has branches, leaves and all that. So one data point and developed into large numbers of trees, and the results are combined for a model. So let's look at how do we produce random forests. So I didn't have that package, so I installed it. Called library of random forest. Then fit that model, predict and forest predict minus house test data of mdev variable, and that gives me 2460, which is quite significant number. So if you remember, for a linear regression we got about 3,500. Then the decision tree gave us about nearly 4,000, and the neural network gave us about 11,000, and the random forest gives us around 2,500, which is quite, I think, fitting. The forest model produces the best fitting the data, I think. So just to recap what we have done, we have investigated machine learning in R. We learned about breaking up our dataset into training and testing section. The example showed how to use predict method from our model. We generated models using linear regression, stepwise regression, stepwise regression, k-nearest neighbor, naive Bayes, k-clustering, decision tree, neural net, and the random forest algorithm. We applied test of the models effectively. So stay tuned for more videos. Have a look at my YouTube channel, my GitHub, and my LinkedIn profile, as well as my WordPress blog, which is. So this is my WordPress blog. I'll be uploading lots of tutorials on data science, AWS, machine learning, lot more to come. Thank you for staying tuned.